All right. Good evening. Okay. So we are continuing with our lectures. We are now on module 25, network security data. Okay, so as a cybersecurity analyst, you will be working with different types of data. Okay, you'll be analyzing different types of data. All right. In the process of finding out whether the security incident is really a security incident. Okay. So the module objective here will be, to explain the types of network security data that is used in security monitoring. Okay. So section 1, types of security data. The first type is called alert data. Okay. So of course, these are messages that are generated by the intrusion detection systems, intrusion prevention systems, of course, in response to traffic that is violating certain rules, or if it matches the signature of a known exploit. Okay? So that is alert data. So of course, in these systems, the IPS and the IDS, what they normally have is either, a database of signature or a database of rules. And I have said it earlier on, saying that relying only on the signature is not good. Okay? Because if the detection system is relying on the signature, then it won't be able to detect unknown or new exploits. Okay? So of course, these alerts can also be generated by SNOT. Okay? SNOT, this is the intrusion detection system. Okay? So these rules are generated by the SNOT. SNOT is the network intrusion detection system. And then these alerts, you can be able to read them and search for them by using applications such as SGUI and SQUET. Okay? In our course, we are going to look at SGUI in detail. Okay? So there is a testing site that is used to determine if SNOT is operating in the test my IDs site. It consists of a single web page that displays the following text. So you can enter this, then the results that are going to get, those are going to indicate whether SNOT is working properly or not. Okay, so now the SNOT has rules. So this is the rule. Alert IP, okay, coming from any source, going to any direction, okay? So if we are going to have this type of traffic, then you have to generate an alert, okay? Of course, SNOT uses the signatures. Okay, so this is SGUI, what we'll be using to analyze data. Okay, so the first column here is the status of the alerts. So you can see the color from light yellow to yellow up to red. Red means that this alert is really serious. We have to do something about it. Okay? Count deals with how many times have you received the same alert. Okay, so we have an alert that we have received. And of course, this is traffic coming from the same source going to the same destination. How many times? And then here we have got the sensor, the sensors. Okay, so where is this alert coming from? Is it coming from the IDS or the IPS? Is it coming from SNOT? Okay, is it coming from the OSSEC and so on? And then, of course, these alerts, we need to distinguish them by using the alert ID. And of course, we have the date and time when the alert was received, the source IP address where the alert was coming from, okay, the source port number, okay, destination IP, destination port, all right, and then the event, what triggered the alerts. So as a cybersecurity analyst, you must know these two to the fullest, because this is the tool that you'll be using to analyze those alerts you have received. So from the skills that you have gained, you are supposed to determine whether this alert is a cybersecurity incident or it is not. Okay? So that is alert data. The other type of data that is there is session and transaction data. Okay? So session data is a record of a conversation between two network endpoints, which are often a client and a server. Okay, so here we have got the client, which is always asking from the server, and the server is providing. Okay, so session data is data about the session and not the actual data that has been retrieved. So these sessions deals with the connection between two endpoints. Okay, so we can be able to identify this session data by using what are known as the 5 tuples. What are the 5 tuples? So here we talk about the source and destination IP addresses, source and destination port numbers, and also the IP code for the protocol that has been used. Okay, so session data includes session ID, right? The amount of data that has been transmitted between the source and destination, and information related to the duration of the session itself. Okay, so this is what makes session data. Okay, and then transaction data consists of the messages that are exchanged during the session. Okay, these transactions, of course, we can see them by using the packet, captures. Okay, the Wireshark, TCP dump, and so on. The transactions that represent the requests and replies would be logged in an access log on a server, okay? A session might include the downloading of content from a web browser shown in this figure, okay? All right, so of course we looked at the Wireshark, okay? So the Wireshark does full packet capture. It can be able to capture the actual conversation, okay, in an email, all right? So the other type of data which is there is statistical data, okay? So this is the data about the network traffic, which is created through the analysis of other forms of network data, okay? So with statistical data, we normally come up with the normal behavior of the network, okay? So if we do have some deviations from the normal behavior of the network or the traffic, then we can be able to know that there's something wrong. We have an example of the NSM2, which uses statistical data, and that is the CISCO Cognitive Threat Analytics, okay? So this is what is happening now. We are trying to use some technologies we are getting from big data, to help us to detect, malicious activities, okay? So the CISCO Cognitive Threat Analytics, it can be able, to find out malicious activities which have bypassed, some of the security controls we have put in place, and as I've been saying, you can't rely on a single technique to protect your organization. So you see, this tool uses machine learning, okay, to detect, anomaly activities. Okay, section 2 deals with end device logs. All right. So as an analyst, a cybersecurity analyst, you must be able to understand how to read the logs. So logs are a different types of data that you'll be working with. So we have host logs, okay? And of course, here we have the host intrusion detection systems, which run on individual hosts. And these can be able to submit the logs to a central server, and you as an analyst, you have to log into this server to analyze the logs. And then Windows keeps these logs in what is known as the event viewer. And of course, Windows keeps 4 types of logs, okay? Application logs, these are the logs that are generated by different applications which are running on Windows. System logs, these are messages such as, the messages coming from the drivers, the processes, and hardware, okay? Setup logs, when you are installing, a software, also there are some logs that are generated there. Security logs, so these are the messages that are generated related to security, such as a log on attempts, okay? Operations related to file or object management and access. And also it has command line logs, okay? So attackers who have gained access to a system and some types of malware execute commands from the command line interface rather than the GUI, okay? All right, so we have host logs. Okay, so various logs can have different event types, all right? So security logs, of course, consists of the audit success or some failure messages, okay? And then on Windows, security logging, of course, is carried by what is known as the Local Security Authority Subsystem Service. So this is the component which is responsible to enforce some security policies on Windows. Okay, and then you have to be very, very careful when this service is running. Make sure that it has to be like this, because malware normally uses this service, okay? But they normally change. So here, instead of I, maybe malware will be using 1, okay? So as you can see here. So of course, then, if you have got such a thing, then of course, malware is running on that device, okay? Very, very important that you must know this as an analyst, okay? Windows also do generate event types. There is an error. So when there is an error, of course, that indicates a significant problem, such as loss of data or functionality. A warning, I think you have seen, sometimes that when you're running out of a drive, you're going to receive, something's going to pop up saying you're running out of space. That event is a warning. And then there's informational event. Of course, this describes the successful operation of an application, a drive, or a driver, or a service. Okay, for example, when you have installed the drivers successfully. Successive audit deals with, how many times, you have logged in successfully on your system. And then failure audit, how many times you have failed to log into a device. Okay. The other type of logs is syslog. Okay, I explained about syslog a number of times already, so I won't spend time, talking about syslog. But the message format for syslog has 3 different components. It has the priority. In the priority, we have the severity. Okay, the severity deals with the, how severe is the message we have received. And of course, for this, we have the values starting from 0 up to 7. Then the facility deals with where did this message come from? It came from the CPU or the RAM, and so on. Then in the header, this is where we have the timestamp. Okay, so this deals with the time when you receive the syslog. Okay, and then the host name. And then here we have the actual message associated with the syslog. Okay. All right. So also the facilities do have the codes that are used from 15 up to 25. Okay. All right. So you can see facilities from 9 up to 15. This deals with the clock messages. So this is severity. Okay. So in the message, when there's this value 0, that indicates that the message is an emergency. So that, of course, will make the system to be unusable. If in the syslog message you have the value 1, then that is an alert. Here it means that you must take action immediately. Okay? 2, it's critical. 3, it's an error. 4, it's a warning. 5, it's a notice. Okay? 6 is informational. And then 7 has got to do with debugging. So you see, it is in these logs that you can be able to know that someone is about to hack your institution. Okay? So priority has the formula, which, we need to multiply the facility by 8, and then we need to add the severity. Okay. All right. So in the header section, of course, the timestamp has to be represented in this form. Okay, the month, the year, okay, the hour, minute, and then seconds. Okay, so you see, if the timestamp is preceded by the period or asterisk symbol, then a problem is indicated with NTP. Okay. All right. So apart from those, we also have the server logs. The server logs, these are the messages generated by the server. And you know that the server, most of the time, is also the target of hackers. Okay. So here we have the Apache access log. So this is the log. So as an analyst, you must be able to read this. That is, be able to interpret this message. And then we have the IIS access log. Of course, this is, Windows Server. So if you see with Apache, it starts with, the IP address. Okay, but for Windows servers, they will start with the date. Okay, all right. So of course you can see we have the dash dsmith, the date, the method which was used, okay, what was accessed. This deals with the browser which was used, by the attacker, and so on. Okay. All right. Security information and event management technology. So of course the same, this is a very, very important tool which can help you to provide real-time reporting, long-term analysis of security events. So you see, it can be connected to a number of devices, the IDS, IPS, firewalls, okay, host-based IDS, server logs and syslog, okay, incident management system, alerts and automation, and so on. So all, it collects information from all these devices, okay? So the popular SIEM system which is there is Splunk, okay? So as an analyst, of course, you have to know Splunk to the fullest, okay? So this tool is able to collect the logs. It is able to normalize the logs. So you see here, it is connected to different systems. And these systems, they do generate, information in different formats, okay? So what the SIEM does is to put that information which is in different formats into the same format so that you can be able to easily understand. Okay. Correlation. So this too is able to correlate. Okay. So this links logs and events, from separate systems or applications. And of course, this is going to speed up the detection or the reaction to security threats. Okay. Aggregation. So this too is also capable of removing the duplicates, all right? Duplicate event records, okay? It is also able to, report in real time, and then also it helps in compliance. Okay, so we talked about the regulators, okay? And the regulators, of course, they do come up with regulations which your organization must follow. Okay, so this too can be able to help you to comply. Okay, so this is the Splunk dashboard.
There's only 2 of us in the class, or what?
Hello? Yes, ma'am. Hello? All right. So Splunk, this is the SIEM tool, which is widely used, in the SOCs. Okay. So because of lack of security cyber professionals to monitor and analyze the large amount of security data, it is important that tools from multiple vendors can be integrated into a single platform. Okay. All right. Network logs. So you see, we have different types of logs. So here you can use the TCP dump or the Wireshark to capture the network logs. Okay. CISCO has the NetFlow, which you can also use, for network troubleshooting, session-based accounting, network planning, billing, and so on. Okay. All right. So this is how NetFlow looks like. Okay. And this is the format of the records which NetFlow do generate. Okay. Okay. Application visibility and control. So this is what is very, very important now. Very, very important to know which applications are running in your organization. And application visibility and control is capable of doing that. Okay. The other application which is able to do that is NBAR. So this is also a CISCO application which you can use to identify which applications are running. Okay. So the tool is able to recognize more than 1,000 applications. It is also able to collect information on how much bandwidth is being used, response time, latency, jitter, and so on. Okay. For management and reporting, as well as, application control and so on. Okay. Right. So port monitoring and application monitoring. Okay. So this is also very, very important to know which ports are open. And from this, we can also be able to know which applications are also running. Then the other types of logs that are there are content filter logs. Okay. So with content filtering, we have the CISCO email security appliance, as well as the CISCO web security appliance. Okay. So these, of course, they'll be going into detail, you know, looking at the information which is coming into the organization and looking at the information which is going out of your organization. Okay. All right. And then logging from CISCO devices. So these are the format of the logs coming from the CISCO devices. Okay. So first of all, you have the time, the CISCO facility. So this is, this is the CISCO ASA. So this is the severity here. We just looked at the severity level, and this is 3. What does it mean? Then the message ID followed by the text, okay? So this is how logging is done with CISCO devices. We also have proxy logs. So these are messages which comes from the proxy server, and very, very important to analyze the logs here, because it is from here where you can be able to know which websites the workers were visiting, okay? And you can see it is also possible to use web proxies to inspect outgoing traffic as a means of data loss prevention. So data loss prevention is also a very, very important tool in your organization, because it can be able to detect when someone is sending sensitive or confidential information from your organization. You know? So it can be able to block that. Okay? All right. So of course, what we have here, this is the proxy logs. Okay? So what we have here, this is the time. Okay? This is the duration. Then followed by the client IP. Okay? Followed by the results. Okay? And then the size of the data. The request, this is the URL that was requested. And then you can see dash represents the client identity, okay? None, this is the peering code or the peer host. Okay, and then this is the type, okay? The content type, okay? So this is how you read the logs from the DNS proxy log, okay? All right. CISCO umbrella. So this was formerly called the Open DNS, which, you know, offers, you know, hosted DNS service that extends the capability of DNS to include security enhancement. Okay. So the CISCO umbrella, you know, is able to, blacklist some websites. It is able to protect your organization from phishing attacks and any other DNS-related security. Okay, so you can see this is the DNS proxy log, how it appears. Okay, and this explains what each of these mean. Okay, all right, and then now, what is happening is that we have next generation firewalls. So these firewalls are able to determine which application someone is using, okay? And of course, who is using it, okay? So some of the common next generation firewall events include connection events. So this deals with the connection logs that are involved, intrusion events, okay, intrusion logs, as well as host or endpoint logs. Okay. So the next generation firewall, you know, what they normally do have, you know, they have intrusion prevention systems, okay, firepower analytics and automation, you know, advanced malware protection, URL filtering, application visibility and control, okay, built-in network profiling. I talked about network profiling yesterday, identity profile control and VPN, okay. So, you know, this is one of, you know, the two that you must have in your organization. Okay, so that is that on network security data, okay? So after having looked at network security data, then we need to look at some of the tools which you can use to analyze data. Okay, Model 26 deals with evaluating alerts. So how do you evaluate the alert? The module objective, of course, you know, we are going to explain the process of evaluating alerts. Okay. Sources of alerts, section 1. All right. So we have a tool known as the Security Onion. So this is the open source suite, okay, of network security monitoring tool that, you know, runs on Ubuntu, Linux, okay. So the Security Onion tools does provide 3 core functions for you as cybersecurity analysts. You know, it has full packet capture and data types, okay. It has network-based and host-based intrusion detection systems, and also it has the alert analyst tool, okay. So this Security Onion can be installed on a standalone machine, on your laptop, or as a sensor, or as a server platform, okay. So this is the Security Onion architecture. You know, do you remember this? I've just talked about this, okay? Different types of data. And then we have the detection tools we are going to use, okay? And then on top here, we have the tools that we use to analyze data, okay? So we have the company there. So this is a web application that allows viewing of pickup transcripts coming from, you know, the Wireshark or the TCP dump, okay? And then Snort, as I said, this is a network intrusion detection system, okay? It sends whatever is happening to it to the school, you know, okay? And then we have got the ZEC. So this, of course, was called the BRO. So this one is also a network, you know, intrusion detection system, which uses a behavioral-based approach, okay? And then the OSSEC, this is the host-based, okay, intrusion detection system, okay? Wazuha, so this one is a fully featured solution that provides a broad spectrum of endpoint protection. And then we have the Suricat, which is also a network-based intrusion detection system. Okay, so in terms of the analysis tools that we'll be using the this GUI. Okay, so this one is going to give us a high-level console for investigating security alerts. Okay. Then we are going to use Kibana, Wireshark, as well as the ZEC. Okay, so you see, I did explain that, you know, alerts are generated from the sensors, then they are sent to SGOI for analysis. So as a cybersecurity analyst, you must work through, the queue which SGOI creates. You have to investigate the alerts one by one, classifying them, and then if you don't have enough knowledge, then you have to escalate those alerts. And of course, if you have investigated this alert, and then you are fully convinced that it wasn't a threat, then you can retire that alert. Okay, so this is GUI here, and I've already explained all this, okay, to you. Okay, rules and alerts. So of course, these alerts comes from a number of sensors. They can come from network intrusion detection system, or from host intrusion detection systems. They can come from asset management and monitoring. They can come from HTTP, DNS, and TCP transactions, or they can come from syslog messages. So what we do have in these systems are the rules. Okay, if the rule has been violated, then we're going to have an alert which is going to be sent to SGOI. Okay. So what we have here is the SNOT rule structure. The SNOT rule structure has mainly two sections: the rule header and the rule option. Okay, so this is the rule. Okay, so we have the rule header. So this is an example of the rule header here. Okay, so the rule header, it contains the action to be taken, source and destination addresses and port numbers, as well as the direction of the traffic flow. Okay, and then we have the rule option. So this is an example of the rule option. And then we have the rule location, okay, where the log is located exactly. Okay, all right. So so what we have in the rule header, of course, these are actions, the protocols addressing, as well as the port information. Okay, and then what we have in the rule option, of course, here we have the variables, okay, and so on. Now, the thing here that you must know is that SNOT uses some, how can I put it? SNOT has these rules, okay? And since we have new different types of attacks, then we also need new rules. So the sources of the new rules are GLP, okay, ET, which is emerging threats, as well as VRT, okay? So these are the sources which do come up with new rules that have to be, that SNOT has to upload. Okay, all right. All right, so that is that on the, we have section 2, which deals with overview of alert evaluation. Okay, so just like I said, all right, when you receive an alert, all right, and if that alert has been difficult for you to analyze, you are not skilled enough, then you have to escalate the alert. Okay, very, very important to do that. Now, how do you evaluate these alerts? Okay, so the method which is used to evaluate alerts was taken from medicine. Okay, so the alert can either be a true positive. A true positive, it means that, you know, this is actually a security incident. Okay, so for example, when you go to the doctor can do a diagnosis and said that, you know, you are sick, but meanwhile, you are not. Or the doctor can, check on you and say you are sick, and for real, you are sick. Okay, so that's how, you know, they got that method from, they borrowed it from medicine. False positive. Yes, you have received an alert, but there is no actual security incident. Okay. Or we can have a true negative. No security incident has occurred. Okay. A false negative. So this is really dangerous. There is an incident, but it is going undetected. Okay. So this is how you do evaluate the alerts. Okay. Using the terms true positive, false positive, okay, true negative, and false negative. Okay. So if you see here, if it's positive, it means the alert exists. Okay. If it's a true positive, it means that the incident occurred. If it's a false positive, it means that no incident occurred. Okay. True negative, no incident occurred. And then false negative. Here we have the incident which occurred. So it went undetected. So true positives are the desired type of alerts that we want. False positives, we don't, want these. True negative, yes. There is no alert and there is no incident. False negatives, these are dangerous. We have an incident which is going undetected. Okay. All right. All right, so we have what is known as deterministic analysis and probabilistic analysis. Okay. Deterministic analysis, for example, for an exploit to be successful, all prior steps in the exploit must be successful. So here, the cybersecurity analyst, he has to know, the steps for the exploit to be successful. Okay, such that when the threat actors have hacked your institutions, then you can be able to determine the steps at which they are and be able to do something. And then the probabilistic analysis, here we use statistical techniques which are used to determine the probability that the successful exploit will occur based on the likelihood that each step in the exploit is going to succeed. All right. Okay, so that is that on evaluating alerts. Make sure that you familiarize yourself with these terms here. Very, very important. Do we have questions on module 26? If not, then we'll look at working with network security data, module 27, okay? The module objective will be to interpret data to determine the source of an alert. So section 1 deals with a common data platform. Okay, so of course, in the security onion, what we are going to be using in our course is not Splunk, but we are going to be using, ELK, which stands for Elasticsearch, Logstash, and Kibana. Okay. All right. Data reduction. So you see, you find that a large amount of data is generated in the organization. Okay. So very, very important that we have to deal with the data. That is what? That is relevant only. Okay. So the system should be able to decide which data is relevant and which one is not, okay? And then the system should be able to normalize data, okay? For example, what we have here, these are IPv6 address formats, okay? Here we have, these are MAC address formats. So you can see that they are different, and you can see also the date formats here are different. What is important is to have, to make sure that the information, all the information that we have received is in a single format, okay? And then data archiving. So data archiving, this is where we, have to keep the information for a certain period of time. Okay, so we have got CISCO here. By default, it has to keep data for at least 30 days. And if we have an incident where the institution has been hacked, then be forced to keep data for a longer period of time until maybe, if, we take, of the situation about what happened to court, we need to keep that information until the court case has been exhausted. Okay. Section 2, investigating network data, working with SGUI. Okay, I won't spend time here, I've explained, but you see, you find that with SGUI, if you go to count, okay, so you find that, and then, if you go to count and then you right click, you are going to see some other tools. So apart from using SGUI, you find that SGUI can also be able to point to other devices. So you can be able to use other devices to analyze the same data. And then also SGUI has what is known as the query builder, okay? So you can be able to come up with queries according to the information that you want to retrieve from SGUI, okay? So this is what I was saying. That is, you have to come to alert ID, not count. You come to alert ID, then you right click. So you find that this same information, you can analyze it using Wireshark, using these other tools like Bro and so on. So event handling. So within this same SGUI, okay, if you have discovered that, the alert is what? False positive. What is false positive? okay? False positive is a situation where we have an alert, but it is not an actual security incident. So, here you can retire that alert, okay? And then if, you can't analyze the alert, then you can escalate that alert, okay? And then this is, ELK, okay? So log stash and bits are used for data ingestion in the Elastic Stack. And then Kibana, this is the visual interface into the logs, okay? So logs are ingested into the Elasticsearch into separate indices or database based on configured range of time, okay? So you can also do some queries in the ELK, okay? All right, investigating processes or API calls. So this is what normally happens on your laptop. So you have the applications, and then these applications, they use system calls to communicate with the kernel, okay? Now, if we have the situation where malware can be able to manipulate the system calls, then that becomes really dangerous, okay? So we can use GUI, to investigate the files in detail. So in GUI, if the cybersecurity analyst is suspicious of a file, the hash value can be submitted to an online site to determine if the file is really malware. Okay, so we're going to do that in the labs. Okay, all right. So very, very important that, you must attend the labs that we're going to do next week, because those are the labs that are going to make you to be, a real cybersecurity analyst, okay? So next week we'll be done with the training. So we're going to do, on Monday, we're going to do model 28. And then on Tuesday, we're going to do a number of labs. And then on Wednesday, also a number of labs. All right, anyway, thank you very much for attending. The thing is, continue doing the chapter exams. Good night. I'll see you next week.
Good night, sir.